What's up, guys? Welcome back to the important part. This is episode 5, going back to our normal schedule of PowerPoint. This time we're doing an AS paper, not a further maths paper. So we're going to be in some increasing difficulty questions. But even if you're a GCSE student, feel free to try some of the questions because you might know how to do them. Alright, so we're firstly going to annotate this question. So we've got a line here. It's perpendicular. We need to find m, and then we got this point here, which means it's a simultaneous equation. So to do this, we got this equation here, we've rearranged it, and then we've divided by 4. We just flip the gradient, make it unnegative, and we get 2 for the perpendicular gradient, which is m. Next, we've got the simultaneous equations of these two lines. I've just rearranged the first one again. Now we just add them together. You get 5y equals 10. It's asking for the x coordinate, so we'll substitute 2 into this equation, and we will get negative 5, or negative 2.5 for x. Right, we've just got some algebra stuff. This shouldn't be too bad for any student. We're just going to take away 2a, and we're going to factorise 2 root a out of the equation. And then we're just going to do some, so we know that 2 root a is 0, so a is 0. And then this next bit, we just divide by 8 firstly. And then you put both sides to the power of 2/3 to make, because 3/2 times 2/3 is 1. So, and that's going to mean that a equals 1/4. Right, so for the next one, even though you could do it normally, we're just going to substitute u as b squared, and we're going to write out like this. Then we're going to factorise it like normal and find the values. So now we have b squared equals negative 9, b squared equals 2, and we know the solution, so we have 3i, but it says real, so it doesn't matter, and then plus or minus root 2, which are the actual art solutions. Right. We have a pretty difficult integration question here for the third question. So we're just going to write the integral out, and we're going to just write it out differently. So 4x cubed is 4x to the negative 3, and then we're just going to integrate it. So just reverse differentiation and add the plus c. If you forget, then I'm sorry, you lost a mark. And we're just going to rewrite it like this with the fraction, because it's asking you to simplify your answer. Next, we're going to find it with these limits here and make it equal to 8, and we're finding the value of k. So we're going to integrate it, and we have these boundaries, so we're going to just do all the stuff, substitute in, take away from the right thing. Sorry, it should be 0.5, I don't know why it says 0.25. And then it all just comes together. You use your calculator, and k equals 4/15. Right, we've got a linear model here. We know that y equals mx plus c. Well, it's h equals mt plus c, because t is always the x-axis time. So this is the dependent variable. We are just going to put these as coordinates, and we're going to find the gradient by using change in y divided by change in x. And we're going to find the gradient, write it as an equation, and then substitute the points in to get the c coordinate. And this is our linear model. And then now it's asking when it's planted, which means at the time of 0, and we're going to substitute 1.4 in, and we can see that 1.4 is around 1.42, so it does support the linear model that we have over here. Alright, next question, we got some easy derivative stuff. We're going to just take the derivative of this, pretty simple stuff, and then we're going to set it to be greater than 0, because it's an increasing function question. Then we're just going to multiply by x squared, and then solve. But it does say x is greater than 0, so there's no plus or minus or anything. Alright, we just got some pretty easy trick here. we're just gonna use the area of triangle rule on this. Half to AB side C equals this, because it says simplify, 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 and that's our show that question. After this, we're going to part B, literally just use cosine rule, substitute the x values in, and just find the answer. The calculator does all the work here. You know what x is already, so yeah. Next, we got some asymptotes here. So, firstly, we're going to sketch C. Any number over x, it doesn't matter, and then it's plus 1. So the asymptote is going to be at y equals 1, because it's plus 1. Then we're going to, because we have this line here, and then this line here, and we're finding the simultaneous equation, they both equal y, so we can just make them equal to each other, and then solve. So we just move the 5 and the 1, and then we multiply by x, and then we move it to make it what it wants here. And then now it's asking us to find the values where L is a tangent. So it's important that it's a tangent because we need to set b squared minus 4ac to 0, because if you think about the quadratic formula, it's plus or minus the root b squared minus 4ac, but if it's 0, plus or minus 0 won't, plus or minus 0, adding 0 and subtracting 0 doesn't change it, so it will be the same solution. So instead of the simultaneous equation having 2 solutions, it will have 1 solution, which is what we want because it's tangent. So we set it to 0, we divide by 8x squared, and we get k as plus or minus root 2. Alright, we got some very fun Pascal's triangle here. We got our power of 6 here, and we're just going to write it all out as powers, and then we are going to simplify, and that is it. That is not that bad of a Pascal's triangle question, thankfully, because Pascal's triangle sucks. Next we have this other model question. So firstly, we just have this model here. Calculate 1st of January 2020, well that's just 1 year, so we're going to substitute 1 into n, get 117. Next, the maximum amount of tin. Well, if you think about it, we want the lowest number here, because we're doing 1200, take away this. So if we want the lowest number, n must equal 20, because then it's 0 squared, and then 3 times 0, and so this just becomes nothing. You can't put n into negatives. You can't make n minus 20 negative, because squaring a negative just makes a positive, and it will just decrease it again. So you just substitute 20 in, and you get this, because it's just 12,200, take away 0. For 3, you substitute 5 into n to find all of the mass of tin mined up to 2023, and then you subtract it from substituting 4 into n, because that's up to that point the amount of tin that's been mined. So that is just 93. And then the limitations of the model, well, you can't make t greater than 20 because it will just become negative, which won't work. Alright,
oh my god, he put it.
What the fuck? Alright, yeah, don't worry about that. Right, anyway.
Can't.
Don't worry about that. Alright, we got some circles here. We have the circles, so we're finding the centre and the radius, and we're finding the points where x equals k. So firstly, let's just do this part. We're just completing the square on both of these. So we'll complete the square of the x's, complete the square of the y's, and then just put them together to get the equation. we just got the centre here. We know how to interpret this set of a circle equation here. So this next part is a bit more complicated because we know that x equals k, so it's a vertical line, and it's a tangent to c, which means that there's only two solutions for k, because k can be two values, one's on the far left of the circle, one's on the far right, and it would just be the centre add 28 and the centre minus 28 on the x-axis. So if you look at this diagram here, we have the centre, and these are the 2 points of k, where it's the tangent, and it's just this extension of the radius into k, backwards and forwards, and that's just how that works. Which you kind of have to visualise, but if you know what you're doing, it works. Next we have some factor theorem. This actually looks similar to the factor theorem question I did a few episodes ago, these first two parts. So firstly we're just proving that it's a factor, f of 4 is 0, fine. And then for b, we're going to firstly divide the cubic by x minus 4, and that's what you always have to do. Get this quadratic, and then factorise it. Then after that, we can see that there are two x minus 4 factors, because there's one just from here, and then there's also one from here over here. So that means, because it's x minus 4 squared, 2x plus 3, there's only two solutions, because both the x minus 4s just equate to one solution. Now, for c, we have this equation here, which is actually different from this one. The plus c has been changed, which means that because it's been lowered, it's been slightly lowered, it means that this part here will go under and then above the x-axis again, which means there'll be three solutions. It'll be go up like this, there's one solution, down there's another, and then here there's another. After this, d, because we're finding f of x plus k, and we're trying to make it pass through the origin. So what we either want to do, because we know this solution is 3/2 from over here, and then we know this solution is 4 because of this. So what we want to do, we either want to shift it by -4, which is this solution here, or we want to shift it by -3/2, which is this solution here. So it can be either of these. Alright, second to last question I'm going to be doing, some trig stuff. This is actually just the GCSE further math identities. There's no like double angle, there's nothing like that here. No secant, no cosecant, no cotangent. So we're just going to do what we usually do. So we're going to use the Pythagorean identity on this, on the numerator, and we're going to expand. Then we're going to set u to cos x, just to make it simpler, so we don't have to write out all the functions, and we're going to write it in terms of u, and then we're going to factorise this top bit, and you can see that these two cancel out, and now we found that this equals 4 minus 5u, which is cos x. This is this first bit. This next bit is just the same equation. We're setting it equal to 4 plus 3 sine x, and we just take away the 4's, because it's just two 4's, to get this, and then you divide by like each other to get -5/3 equals tan x, and we use the other identity here, and these are the answers. You just find the principal value and then add 180. Alright, this is a very nice question, especially if you're interested in calculus. It's a very nice question here. It works well. It's 7 marks, so you're going to need to do well if you want to get a good grade. And you see we're finding the area under a curve here, and the bounds are the origin and the stationary point here. So firstly we're going to find the derivative, and we're going to set it to 0 for the stationary point. Next we're going to quadratic formula this and get the solution of x equals 4, x equals 5/3. You can tell here these are the two stationary points. We want the one that's furthest to the right, because that's the one we're looking at. So we know that it's going to be x equals 4, because it's bigger than 5/3. Then we're going to go for an integral, because we're finding the area under a curve, of course we are. And we're just going to integrate it, and we're going to substitute 4 in, and then that is our answer. That was a very nice question there. But anyway, thanks for watching. That might have been a bit fast, but again, just pause the video when you need. But see you next time.